So in the end, after about 6 meetings from the period of summer of 2010 till January 10th of this year, the experts around the table and everybody participated very, at each meeting in quite detail, came up with a regional scale classification that was actually had 2 levels to it. The first level we termed coastline environment level. And it teased out to that whole segment of the Atlantic coast, the Bay of Fundy, and the Gulf of St. Lawrence, which probably wouldn't take experts to come up with that. It's quite intuitive, but it was very obvious in the end. The second level has actually two levels inside of it. One we term the coastline segments. So these are all contiguous segments of coastline. We don't have pockets that repeat along coastline. Each classification segment is contiguous within itself. So we have what's classified as coastline segments and coastline segment variants. And the reason why we came up with those 2 is because we started from the bottom up. We actually started with the coastline segment variants and had quite a number of them and felt that that was really too many to work for the Marine Protected Area Network planning. So we could see that certain coastline segments adjacent to each other were quite similar and could actually be lumped into a single unit, and that is our primary unit of classification. It's called coastline segments, and from there all of those coastline segments could be combined to form the coastline environment. So the methods that we used were twofold. One was to take from the existing work that was done by John Roth and Mark Zacharias in marine conservation ecology, what the primary factors were that dominated the species diversity and distribution patterns at the regional scale. And so those 11 factors were the top ones that were considered. And then secondarily, of course, we had to work with only data that was available region-wide. So some of those were a bit more difficult to discern. So we acquired the spatial data at a regional scale. We met those several times and to determine these patterns of breakpoints. So this was very much a Delphic approach. It wasn't, we didn't do data analysis. We relied on the experts' knowledge of the area and we really rigorously knowing what the data meant. So it's not just taking someone else's data, but it was actually their data. And what we found was the breakpoints were always where one or multiple variables clearly broke their patterns. So we were really looking at patterns, and I was quite excited to actually look at Aaron's shoreline classification for Prince Edward Island, and instead of looking at all the details, I was actually stepping back and seeing patterns, along the coast. So that was what was done here. And one other very important consideration that we did make was that bays should be kept together, and that was to preserve the influences of the embayment current patterns as well as the watershed nutrient runoff and sedimentation. And when you are looking at shoreline classification, and of course the terrestrial part is the dominant feature and geology plays such a big role, sometimes you have to step back and say, no, we can't break it in the middle of a bay because it just does not make sense from a marine or oceanic standpoint. So what we found at the coastline environments level was that the factors that were most important for determining these scale breaks were major oceanic changes as well as major topographic and geologic changes. So just to demonstrate, this is the area. The pink is the what was determined to be the Atlantic coast, and the orange is the Bay of Fundy. So that the break point between the Bay of Fundy and the Atlantic coast was where that drastic change in tidal range was, and the difference between an 8-meter level or more in the Bay of Fundy as opposed to approximately 2-meter change along the Atlantic coast. There was much higher turbidity in the Bay of Fundy. The Atlantic coast is very highly exposed. The Bay of Fundy is a little bit more sheltered. Very different currents. We have a longshore southerly current on the Atlantic coast versus a very specific counterclockwise gyre in the Bay of Fundy. And there is this dominant linear topographic feature, that basaltic ridge that goes to the tip of Briar Island, and the outer extent is the 100-meter bathymetry, and so that's why it probably looks a little bit funny to most people coming off of Briar Island. It's not a straight line. And on the other end of the scale, in the bioregion, the Scotian Shelf bioregion, the breakpoint between the Atlantic coast and the Gulf of St. Lawrence was due to changes in the amount of ice coverage. The major oceanic changes between the southern Gulf of St. Lawrence and the Cabot Strait in temperature, salinity, and depth. As well, the exposure, very sheltered southern Gulf of St. Lawrence versus the more exposed Cabot Strait, and very different landscape features at the top of Cape Breton Island, as well as some major geologic changes there. So at the segment variant level, it was found that the geologic components were very important, and it was much more important to know whether it was bedrock or non-bedrock, and if the bedrock was there, whether it was a hard bedrock or a soft bedrock. And it really didn't matter what the bedrock type was. And for the subvariants of secondary importance were some of these factors. So just two examples of the data. We used multiple layers. These weren't just the only two, but one that played a very significant role, of course, is the geological map of Nova Scotia. And you can certainly see the components that cause the shoreline to be different places, and the corresponding oceanographic factors, specifically benthic temperature, played a key role, and you can see a big difference along the Scotian Shelf side versus getting into the Bay of Fundy. So here are the preliminary results, which after several sessions we were very excited to pull together and feel quite confident about. You can see that there are 23 segments, and the A's and B's and C's represent the variants. This is being reviewed, so that on the New Brunswick side we did a quick first pass at it. It really needs to get more review by some of our New Brunswick counterparts. There's a meeting planned in Fredericton in the near future. There's a CSAS publication which is being written and hopefully will be out by the end of February. The CSAS RAP, the Canadian Scientific Advisory Secretariat Regional Advisory Process for the Marine Protected Area Network Planning, is scheduled for early March, and so we're really hoping to get scientific validation of the Delphic process that was run. We are really hoping to get a multivariate analysis done of some of the data, so that that can also help justify some of these breaks that we did, and to complete that subtidal section. So not just the coastline, but the subtidal section and the whole bioregion will hopefully be classified. In the long term, our wish list is actually to do some comparison with biological data, to write some other publications, other scientific journals, and certainly public outreach, because it is quite interesting when you step back and categorize segments of shoreline and see what's similar along the coastline and where it actually makes these changes. It might be interesting for all sorts of different purposes. And there's a lot of interest in continuing the rest of New Brunswick on the Northumberland side, as well as PEI, and maybe even Newfoundland. So